Okay, algebra. I'm going to go through section 8.1 with you. I am gone today, and hopefully this is the last time I'm gone for a little while for your class. But we're starting the chapter on logs, and I'm really excited about this because logs is one of my favorite things to teach. And so logarithms go with exponential functions, which is what we learned in the last chapter. So I'm going to do kind of like a little preface to this and show you why logs are important, I guess. So in the last section, if you want to write this off to the side over here, this is, we learned exponential functions where it was like a equals pe to the rt power, which was one of the equations that we had. And so it was like, if you have $500 and you invest it at a 5% interest rate, which is 0.05, and you do that for, let's say, 12 years, I don't know, what would your after amount be, or like how much money would you have at the end? Okay, so that was one thing that we looked at. But then now we're going to get to the point where it's like, okay, instead of me saying that I don't know how long I'm going to leave it into a bank account, but I want to know how long it will take me in order for that $500 to become 700, right? And then we're solving for the t that's up in the exponent. And the problem with doing that is, like, how do we get the t down out of the exponent, right? Like, we can't just divide all of this off and make it go away. The t we have to solve for in a different way, and it is using logarithms. So we weren't able to do that before. Or maybe like they will say, okay, we're going to invest it for 20 years, but what interest rate would we have to have in order for it to turn into $700? So maybe we're solving for the interest rate instead of solving for time, which is also up in the exponent. So we have to use a log to get it out of there, right? So that's why logs are important. That's only one, example of when we would use a log. There's many different other things that logs are used for, like in the Richter scale when you're dealing with magnitudes of earthquakes, or when they're talking about intensity of, power or things like that. Those are also applications of logarithms, but this was just one example that we will see later on in the chapter. Okay, so log functions, they start off with like the graph of a log function. So when we talked about like 2 to the x power being an exponential function last time, if you were to graph 2 to the x power, it is this guy, this little blue one right here. And we said that he will always go through the point 0, 1 until we move him left and right and up and down and all that stuff. He will always go through that point 0, 1, and he'll have a horizontal asymptote that goes through right here. Okay. And so a logarithm, what he will look like is, instead of 2 to the x power, he will be log with a base 2 of x. So it's kind of like a subscript, like log x. Those are all in the same playing field, but then like the 2 is like down lower. It's like your subscript. And log base 2 of x is this little green guy right here. They call it 2 to the y power, which we will never see ever again. So you can cross that off if you want to. I don't know why they call it 2 to the y power, but that's the same thing as log base 2 of x, okay? And he will always go through this point 1, 0. So if you notice like 0, 1 and 1, 0, he'll always touch that point. So be looking for this little dot every time, that 1, 0. And he will have a vertical asymptote. So he'll start and then he'll curve, and he kind of makes like a, I don't know, like a reverse L. Like an L will go this way. He's like a reverse L, so he's like going up like this, okay? So something of that nature, that's what a log looks like. The base of the log, so like log base 8 versus log base 2, that will just show you the degree that he is going to go up. So like log base 8, he will go like this. He'll be a little bit more narrow. Kind of like 8 to the x power is going to be a little bit more narrow that direction. So he'll still cross through. He'll still have his vertical asymptote. He'll still cross through at that place, but it'll just be like how compressed he is, I guess. And there is that. So that's logs. Let's talk about the conversion. This is the fun part. Okay. I hate doing this. Okay. Example 1. This is the fun part. This is converting between a log and an exponential function. So here's how this works, right? Let's say you have 2 to the third power equals 8, right? Like that's something that we know to be true. This is an exponential function, and if we want to convert him to a log function, he will be log. The base here will become the base here, log base 2, and the other two numbers will switch places with each other. So it'll be log base 2 of 8 is equal to 3, and that's how you convert between the two. The base of the exponential function, this 2, will stay the base of your log. So that number will stay in the same spot, but then the other two numbers switch. So here we're converting back. We have a log and we're trying to convert back. So the deal here is 4 will become my base. Oh, I don't like this. Get rid of that junk. 4 will be my base. Then these two numbers will switch places. So it will be 4 to the third power equals 64. Like these ones are really super fast to like convert. You have your base here. This is 3. He is 3 to the negative fifth power equals 1 over 243. And that's how he gets switched. So 3 is your base. These two numbers swap places. 3 to the negative fifth power equals that. Okay. C would be your base is 9. 9 to the 1/2 power equals 3. The 1/2 power, by the way, just means the square root. So the square root of 9 is 3. That makes sense. Just like up here, this negative power means that you are making it into a fraction. So 3 to the 5th power is 243, but 1 over 243 would be negative 5th power. So this is your conversion. Okay, you're just converting from log to exponential function. There's no solving for anything. We're not going to solve anything yet. We're just converting from one form to the next. Okay, in example 2, we're going to be converting back. So these are all exponential functions, and we're going to try to make them into logs. I'm not going to go along with their work here. First things first, we need to write log, and we need to have a base of our log, and the base here is 7, so that's going to be my 7. And then I just switch places with the other two numbers. So 117,649 equals 6. Those two places switch. Okay. Same thing here. I've got log, and the base of my log is going to be 8 because that's the base there. So I just kind of like write him as like a subscript down lower a little bit. And then these two switch places. So 1 over 512 equals negative 3. Okay. Last one, log with a base of 8 of 4 equals 2/3. Okay. Just getting used to like the verbiage that you use, like how you say this is a little confusing. So this is log base 8 of 4 equals 2/3. Log base 8 of 4 equals 2/3. Okay. So, what is happening? So little bit getting used to how that works, but you know, like we'll say that a bunch of times over the course of the next section. What are we doing here? So you'll get used to how that is stated, I guess. All right, let's go to example 3. Now we're going to actually be evaluating something. So here's the deal. My brain can kind of think in exponential functions. My brain cannot think in logs, in terms of logs. So if I ever get stuck and I'm in log form, I a lot of times will convert to an exponential form. But the problem is here that we just converted from log to exponential and we had it equal to something, right? Like we don't know what it's equal to. So here's what I'm going to do. When they say evaluate or when they say solve, and they only have two pieces here, I'm going to say equals x. I'm just going to throw a random variable in there, and then let's see what we can do here, okay? I'm going to take this statement, which is in log form, and I'm going to make him into an exponential form, okay? So this says 216 is my base. 2 the x power equals 6, okay? And what I'm doing is I'm trying to figure out what base what exponent I take 216 to get 6, okay? They say right here that 6 to the third power equals 216, okay? So let's see. How do I get, if 6 to the third power equals 216, then how do I get rid of, or how do I undo that? Well, the opposite of the third power is the cubic root, right? If I take the cubic root of 216, that will give me 6, right? Like that's what that is. But what is the cubic root as an exponent? Well, that is like saying 216 to the 1/3 power. I just said like 9 to the 1/2 power was the square root. 216 to the 1/3 power is 6. Another way of thinking about this is, let me go down here. I didn't want to erase all that. Let's say, okay, 216, I rewrite him as a base of 6 to the 3rd power, right? Like I just rewrite him as 6 to the 3rd power, and this is equal to 6. So kind of like what we did in the last chapter, 216 is 6 to the 3rd power, and then I combine these two, so this is 6 to the 3x equals 6. Okay, now the exponent on this one is to the 1st power, and then I can cross these off, right? So 3x equals 1, and then I divide by 3, so x is 1/3. That's another way that you can think about how to solve that. Okay, so that is evaluating logs. If they don't have 3 pieces, set it equal to x, and then just use that to solve him. Okay, I don't like their work. Don't go along with that. That's a little bit more confusing than it needs to be. Okay, all right, example 4, finding inverses of exponential functions. Here we go. They say the air pressure of an aircraft outside of an airplane can be determined by this thing. Okay, now this whole thing, it looks like it's down below, but this is actually the exponent on top of the 10. It's just that this is so big that you can't really see that very well. So if you rewrite him, I'm going to write him over here. P equals B times 10 to the power of negative 9h over 100. That's what they intend for that to say there. That is all an exponent on the 10. Okay, then it says the air pressure. Oh, B is the air pressure, and H is the altitude, so like how high up you are. If the air pressure is 14.7 pounds per square inch, okay, that means I'm going to plug 14.7 in for B. That's what the air pressure stands for. Write an equation to find the height of the aircraft when the air pressure is known. Okay, so here what they're wanting us to do is they're wanting us to solve for H. So kind of like I set up above, where like they will now have us solving for time. Instead of solving for this A over here, they'll say, plug in this number and let's solve for H. So what they want us to do is they want us to like unwind this equation to have H by itself instead. So follow along here. This is kind of a little bit maybe of a harder problem to begin with, but you know, like it hopefully will make sense. Now, most important thing is that 14.7 and 10, you cannot multiply those two numbers together because the 10 has a power on it, whereas the 14.7 does not. So then where do we start? Like, what do we do first? So what I want to do ultimately is I want to get everything moved away from this H and move to the other side. I don't know why it's doing this. Here we go. Okay. I want to move everything on the other side of the H to the other side. So I'm going to divide by 14.7 first. Okay, and this is going to look kind of weird just because like we don't have a number in for P. But we've got 14.7 on the bottom equals 10 to the negative 9h over 100. Okay, now here's the deal. This now is an exponential function, and what I'm going to do is I'm going to make him into a log function, okay? Notice that here's my exponent. So now I'm going to switch him to log version, and he will be a log. The base here is 10, okay? And this looks kind of funny. These two pieces are going to switch places. So log base 10 of P over 14.7 equals negative 9h over 100. Okay, that's how he works. So I switched him from an exponential function to a log function. Log base 10 of that stuff equals negative 9 over h over 100. Then what I'm going to do is I'm just going to solve for h here. So I'm going to multiply by 100 to get him to go away. So I have 100 over here, 100 log base 10. And then I am going to divide by negative 9. So divide that whole thing by negative 9. So here's what h is going to look like. H equals 100 log base 10 of P over 14.7 divided by negative 9. And that is what he will look like. Okay? So, yeah, there we go. I'm going to, let's do this. We're on example 4 now. Before we go into graphing, I might save that for tomorrow. just because I don't want to overload you. I know logs and exponentials, like day one of them is a little bit intimidating. So I'm just going to have you, we're not going to do graphing yet. We'll maybe save graphing for tomorrow, because there is quite a bit of it, I guess. What I want you to do is, yeah, let's do this. Do just this part of the homework assignment up to 26, or up through 22, I guess. I had to do 1 through 12 all, and those are just getting used to writing exponential to log form and log to exponential form. So like if I do number 1 with you, okay, this is a log function and you're trying to make him exponential. So the base of my log is 15. So now I'm going to change him to 15. These two switch places. So 15 to the second power equals 225. Okay, that is it. That's all you have to do. Okay. In number 7, this is an exponential function and you're making him into a log. So you need to have log, and we have the base of our log. Base of the log is going to be 2. So I make him little. And then these two switch places. So log base 2 of 128 equals 7. Kind of like they have it written right here. Log base whatever of whatever equals whatever, right? It's along those same lines. This is the form that you're trying to write him in. Okay, so get used to doing those on 1 through 12, and then try to do 14 through 22, the evens, okay? And that will, yeah. On 14 through 20, these are the ones where you're going to set them equal to 0. Or, excuse me, equal to x. Equal to x, whatever any of these are, equal to x, okay? So like 13, I know you didn't have to do this problem, but if I set them, that guy equal to x, then I make him an exponential function. So I switch him around, and I say 2 is my base, 2 the x power equals 64, and then I have to solve for x. So I think, how many times do I have to take 2 times himself to get 64? And I believe it is 6. So that's how you go about solving those guys, okay? So set him equal to x, and then you will rearrange him into an exponential function and solve and see what you can get, okay? And that is that. And then do 22, okay? So attempt those, get through those. You should be able to do that much, and then we'll graph some more tomorrow.